Seismic surveying is a key part of hydrocarbon exploration and development. Since the mid-80s, Petroleum Development Oman uses the three-dimensional seismic method to map large parts of the subsurface in its concession area. In this film, we will show you step by step how the three-dimensional seismic operation covering the Farhud oil field is planned and executed. Many months before any of the field activities takes place, preparations start in the head office of PDO in Muscat. Specialists from the Geophysics Department, supported by the Farhud asset teams and the Survey Department, put significant efforts into optimal design of the seismic campaign. A program of planning meetings involving both PDO and the seismic contractor are held to discuss the logistics and ensure that all the health, safety and environmental aspects of the project are considered. Preparations include extensive scouting, HSE workshops and job safety analyses. In addition, an ecological assessment and environmental impact assessment are carried out by a specialist environmental company. PDO and the seismic contractor take a great deal of care to mitigate the level of environmental impact. Satellite imagery, aerial photography and elevation data is used to create an accurate model of the Farhud survey area. This model is very important for the logistical planning and preparation of an efficient operation. The model also helps to identify environmental and safety hazards. After more than 6 months of thoughtful access preparation by an advance crew, the main seismic crew arrives in Farhud. To undertake an efficient 3D seismic survey requires the mobilization of more than 300 crew members and a formidable amount of equipment to the site. More than 100 accommodation units, 12 vibrator trucks, more than 250 kilometers of cables, 54,000 seismometers, a recording truck, 120 vehicles, offices, workshops, kitchens, a clinic, ambulance, generator.
Wow.
The varied terrain includes wadis, rocky and sandy plains, mountains and oil field infrastructure. The mountainous area of Farhud has steep slopes, cliffs and overhangs, and many of the wadis are filled with small and large boulders. All the line workers required to enter the more difficult rough terrain are trained and assessed by professional mountaineers. The mountaineers themselves are the only people allowed in the most difficult terrain, the so-called red zones. In a seismic survey, vibrations are created on the surface and their reflections from the subsurface layers are measured at thousands of locations. It all starts with determining these locations. For the entire Farhud survey, an area of about 150 square kilometers, this means hundreds of thousands of marked points. Maintenance of the more than 140 vehicles and trucks requires a well-equipped vehicle maintenance shop. The work continues every hour of the day to ensure the operation is run as efficiently as possible. Also, the seismic line equipment is thoroughly tested and, when necessary, repaired before being deployed in the field. Then hundreds of crew personnel go into the field to lay out the many kilometers of cable and to plant the detectors or geophones. As far as possible, the cables are laid out along straight lines, but this is not always easy or possible in this difficult terrain. 6 detectors are planted at 12.5-meter intervals along these cables. Once the crews have deployed enough cables and detectors, the next phase in the operation is ready to start. To generate the vibrations, so-called vibro-size units mounted on all-terrain buggy vehicles are used. A heavy plate on each unit is firmly pressed onto the ground surface, and the units vibrate at varying frequencies for some 15 seconds. In this way, a train of sound waves is sent into the earth. The trucks then lift their plates and drive to the next vibration point where the same procedure is repeated. The vibro-size units are used in all the accessible parts of the survey area, including the mountainous areas, the wadis, the camp, and as close as possible to pipelines, to obtain an adequate image of the subsurface. In the Farhud program, 120,000 points are vibrated. In total, 10 vibro-size trucks are deployed in groups of 2, so that at any given time, one group can be vibrating while the others detour to their next location. Vibrations or sound waves are sent into the earth and are partly reflected as echoes when the composition of the earth changes. For example, from a sandstone to a carbonate. These echoes are registered by a network of small detectors called geophones that are positioned along the cables on the surface. The geophones convert the echoes into electrical signals. These signals are transferred to the recording truck via the kilometers of cable. A few seconds after the vibro-size trucks stop vibrating, the measurement is complete, and one can see the first results in the recording unit. The arrival of each echo is registered very accurately. The time between the start of the vibration and the arrival of the echo gives information about the depth of the layer interface that causes the echo. In this way, information about the subsurface layers is gathered to a depth of several kilometers. The signals or seismic data are recorded on magnetic tapes. The recording truck is the center of the field operations. The entire survey area is divided into strips. Once each strip is completed, the equipment is picked up and redeployed on the next strip. This so-called roll-along technique allows the crew to cover the entire area in an efficient manner. At the end of the day, all staff report back to the seismic base camp and complete their journey management. In this way, the crew managers ensure that all personnel are accounted for. In the field office, the quality of all data is continuously checked to ensure that all points have been vibrated and the data meets the technical requirements. The resulting coverage is continuously evaluated during acquisition. With this approach, the actual coverage achieved during the survey is extremely close to the pre-planned one. In such a difficult terrain, this is a great technical and logistical achievement. At the end of each day, the crew review the operations and discuss the plan for the next day.
Every day, but I think tomorrow people are going to really want to come back to camp and go home to their families, okay?
But for some people, the day is still not yet over. The equipment needs to be checked and vehicles maintained to allow the activities to continue the next day. Then it is time to enjoy a shower, a meal, and have the well-deserved rest. When working in these extreme conditions, with temperatures reaching 50 degrees centigrade and difficult terrain conditions, health of all crew members is of crucial importance. A medic with a well-equipped clinic and regular monitoring of the workforce all contribute to achieving the required health standards. And the next day, all the crew is again ready to deliver quality work in the same extreme conditions. So, after more than 12 months preparation and 6 months of data acquisition, during which the crew consumed some 15 million litres of water and 1.5 million litres of diesel, the most complex seismic campaign in Farhud comes to an end. The magnetic tapes containing the recorded measurements are sent to PDO's head office in Muscat. Here, complex mathematical processes are applied to these data with the use of fast computers, resulting in a new, high-quality picture of the Farhud subsurface and its oil reservoirs.
And one big horizon already in here. And we can also see here, that's one of the nice things, that under the jebel here, some areas are extremely
Then,
noisy.
geoscientists use the data for detailed interpretation to determine the well locations to optimally develop the oil field. With these new seismic data, Petroleum Development Oman aims to improve the future development of the Farhud oil field. The success of this most complex seismic project in PDO's history is of crucial importance to PDO and to the Sultanate of Oman.